Okay, guys, so our next topic here is going to be limits that involve, well, you'll see. So let's start this example 1 here, okay, for ourselves. Right, remember techniques we've done so far for evaluating limits is to look at it graphically and to trace it graphically. We've looked at using a table of values, we've looked at direct substitution, and one of the things we remember from direct substitution is that when you have a limit of, when you get 0 over 0 in the limits, it tells you you're missing something, okay? Techniques we've seen for doing that is trying to reduce it. Sometimes we've rationalized the numerator, the denominator, but what if we had something like this? The limit as x approaches 0 of the sine of 3x over 2x for ourselves, okay? And if we plug in, if we just do a direct substitution, we would get sine of 0, which is 0, and over 0. So again, remember 0 over 0 tells us we're missing something. So this topic is trig limits that we're going to be working with, and especially with a 0 over 0, right? It tells us that we're missing something. It does not tell you that it's an open circle on the graph. A lot of times it is an open circle, but it just tells us that we have to try to reduce it. Now, somebody might say, hey, could I use, one of my angle formulas? Because I know the triple angle formula. Not many people know the triple angle formula, but some people do. And you could try to use that, but you're still going to come down. You're still going to have an issue later with what's there. So let's just take a look at this and think about this in terms of using our graphing calculator, our graphing utility, okay? So if you're, and you could use Desmos, but just for the ease of making this video, I'm going to be using the graphing calculator. Okay, so first of all, make sure you're in radians mode. All right, all calculus is in radians mode. There's no such thing as degrees. All right, so you go there and you, I'm going to put in the sine of 3x for my equation, making sure I put parentheses around. Right, the 3x, notice the parentheses there, and then I'm going to put extra parentheses because my old school calculator doesn't always. I'm not always clear about its order of operations. Okay. And 2x for the denominator. Okay, so I'm going to go with that the tried and true technique that always works is, hey, if when in doubt, look at the graph. So we have sine of 3x divided by 2x. Be very, very careful with your parentheses, especially with the denominator, that the 2x is really in the denominator. A lot of people don't make sure it's in there and they get a totally different graph. Okay, I'm going to go to zoom. I'm going to do zoom. I think I'm already zoom standard, so and when I zoom standard, it's not going to look too good, so I'm going to go back and do zoom, decimal, because that will actually make it more of a square. Right? So if you want to make sure that your x and y have the same units on it, right? Then we have that. So if we're going to trace our graph, we're going to look at this one, right? And I trace it. Looks like it's getting pretty close to 1.47. The other side 1.47. So it definitely looks symmetric. I'm going to go and use my table set to help me out because I feel like, or maybe I could zoom in a little bit around there. Let me do zoom. Right, that might be easier. Right. Zoom box. Did I do zoom box? Let me make sure I did zoom box. Zoom box. I'm going to pick the area I want. Okay, zoom in right around there, because remember, we're just caring about what happens as we approach 0. Okay, if I trace it now, 1.498, no, jeez, look at that, right? No, negative. So 1.499, right? 999. Looks like it's pretty close to 1.5 to me. I'm going to go with 1.5 as my best guess on that one, right? Or 3/2. I don't like decimals. Okay, so let's try another one here. Okay, and now let's try it now with 4x over 2x. Okay, so I'm going to go back and I'm going to do the same thing there. Right, and I'll put this in. Okay, graph it out. Oh, my zoom's off because I'm going to go back to zoom. Whoops. So forgot that step, right? Zoom, and then do zoom standard. Okay, for ourselves. Okay, you can see that area. I'm going to zoom in right around that, or do a zoom box. Let's go zoom in. Okay, I want to get close to where I have it. Zoom in, see what I get. Okay, that looks much better. If I trace it again, right, so you can just do this, right, 1.98 just to the right, 1.94 just to the left, right, zoom in. It just seemed like too much variation to me, so I'm just going to hit zoom in again. Okay, and trace it again. So this is all you do. You just kind of go through and get it closer, trace, there we go. Just to the right, 1.999. Just to the left, 1.999. It appears that it's approaching 2 for ourselves. Okay. And, you know, we can play around with some other ways. Let's see, let's make it now instead sine of 3x over 5x. Let's try that. Okay, I'm going to put that in. Okay, I'm going to go to zoom 6 to get that zoom standard for myself, which is we know isn't going to be great. Okay, and then I'll do zoom. I mean, maybe I should use window, right, just to see what's going on there, so I can see it. I'm going to do zoom decimal, so I felt like that helped me before to see things. Oh, okay, I can see where it is, and let's do the zoom box right around 0. There's my. Okay, I'm just playing around, right? This. Okay, the better you zoom, the easier this gets here. Okay, I'll trace it up. If I trace it, 0.599 or 0.5997, oh wow, look at that. So I'm just to the right, it's 0.5999, and just to the left, it's 0.59999. So it's basically 0.6, which is the same as 3/5, 6/10, 3/5. Okay. So if we were in class, we'd be doing, you should do your own one and try to find a pattern for this. And if you look at these, right, and you look back now, we're going to skip ahead because I've already 8 minutes into the video, right? And we'll look at this and see for myself, hey, look, 3, this one came out to be 3 over 2, this one's 4 over 2, this one's 3 over 5. So basically, we have a property here, and I told you that 0 over 0 tells you missing things. So the fourth way you can evaluate limits, we've talked about 3 ways so far. Fourth way is just to have a property. And the property here is the limit as x approaches 0 of the sine of ax over bx equals a over b. And now that we have that property, we can use that property. Now, for full disclosure, right, the technical property is that it's sine of ax over ax, and then you have to manipulate to get those two equal to each other. I just don't think that's worthwhile for ourselves, especially with other techniques that you'll see later on with limits. When I'm saying later on, like in Calc 2. So we're just gonna stick with that property, and if next year your teachers want to dissect it further, they can dissect it further. I don't think they're going to. I think they're going to let you use that one. Okay, so this means that from now on, when we're doing these, if I said, and the directions say evaluate each limit, going forward here, I do not want you to use the graph. I want you just to say, for me, okay, say the limit as x approaches 0 of the sine of 6x over 5x. I want you just to use the property and say, okay, I know this limit's going to be 6/5. If I were to graph this out, right, this gets infinitely close to a point. There would be an open circle at 0,65, 6/5, okay, for ourselves. So it's still domain restriction, tells us what we get infinitely close to. Please, please, please be careful though, right? Just because we see the sign in here, some people say you just wrote the same problem. I did not write the same problem. I wrote the same function, but we are now approaching infinity instead of 0 here. Okay, so if we think about this, right, this one's going to be a much different graph. Okay, let's talk about it theoretically. Theoretically, the top here, right, this, right, top. When we have rational functions, we think about what happens at the ends. So this top here is going to be oscillating. It's oscillating between -1 and 1. Okay, we know it has to be between those two. The bottom is 5x. It's just basically going to be 5x. Okay. So we can see that this function right here is sandwiched between these two right here. Right? This is a lower bound for it. This is the upper bound for it. Okay? So this function is sandwiched between an upper and a lower bounds. Okay? Now the thing about this sandwich theorem that we're talking about right here, okay, is that if I'm approaching, I can evaluate this limit right here. The limit of that is 0. I can evaluate this limit right here. The limit of that is 0. So if this function is sandwiched between these two functions, and these two functions, the upper and lower limits, both are approaching 0, right, then it's safe to say that this one has a limit of 0 as well. And that's what the sandwich theorem actually says. If you have an upper bound and a lower bound, and they are going to be approaching the same limit, then the function that's in between also has to have the same limit. We can call it sandwich theorem. I just think of it as logic, right? If you understand this whole idea of the rationals and whether the numerator and denominator are growing faster, right, then you don't really need the sandwich theorem, right? You can say to yourself, oh, this one is growing to infinity, this one's stuck between -1 and 1, so something -1 to 1 divided by a really large number is going to be approaching 0. So, right? Okay, I mean, you do it however you want, right? If you want to technically use the sandwich theorem, great. I'm never going to ask you to show your work for a sandwich theorem. I want you just to be able to think about it, right, and understand the logic there. So it's really not that big a deal. Okay, now then some people say, okay, does this property, this property up here, work for other functions? And we do have to be careful, because if we were going to do cosine of x here, and if we were going to try to use that property, we'd say, oh, the property tells us it's 1. The property is for sine. Okay? So, and remember, the sine was 0 over 0, right? So if this isn't 0 over 0, then we definitely can't use that property. So let's see what we get. We plug in 0, I get 1 for the numerator. I get 0 for the denominator. That does not tell me I'm missing something. That tells me I'm approaching an asymptote. Okay, so let's think about our two directions. If our two directions agree, then we can get this. So if I'm doing just from the left, the top is approaching 1, the bottom is approaching a negative small, so this is negative infinity. So from the left, it's negative infinity. From the right, same function, it's going to be approaching 1 on top and approaching 0, a positive direction, so it's infinity. So this one does not exist. Okay, so we want to be careful with this property. It is very specific about it's a sine of a function, sine of that quantity, sine of ax over bx. Okay, so it must be sine, it can't be cosine, right? It must be approaching 0. It cannot be approaching a different value there. Okay, so keep those in mind as we try to do the later examples as the next video gets into the harder examples.